In the final part of this series where we learn how to factor by grouping, we're expected to factor what is considered to be the hardest type of these questions. Starting with question A, we have x squared minus 2ax plus a squared minus b squared. This took me 2 attempts overall, and in my first attempt, I started to factor by grouping right away. I didn't rearrange any of the terms. I looked at these 2 terms individually and these 2 terms. With the first 2, I factored out an x, and I had inside the brackets x minus 2a, and for these 2 I figured that they were a difference of squares, so I broke them down into a minus b and a plus b. This was attempt 1. I knew I could do better, so I tried it again. This time what I did was I considered these 3 terms as a perfect square trinomial. Let me show you what I mean. I have x squared minus 2ax plus a squared minus b squared. This is a trinomial, a polynomial of 3 terms. And you can test if it's a perfect square trinomial by square rooting the a and the c term. I'm going to square root this, and it turns out that it is a perfect square. And a squared square rooted is also a perfect square. That's one of the criteria. So another criteria is that if you multiply the a and c term, we end up with x squared, a squared. Square rooting this should give you half of the middle term. So if I square root this, I end up with x a. The coefficient here is 1. Dividing 2ax gives me 1 over xa, or ax. Therefore, this is a perfect square trinomial. And because it is, I can break this down into x, this symbol here is minus a squared. All of this has become the following expression. Now we also have this minus b. Now if you look at this as a whole, this is a difference of squares. This is a perfect square, and so is this one, leaving us with x minus a plus b and x minus a minus b. Take a look at the 2 attempts. In the first one, we ended off with 2 terms. This was one of our terms, and this was the other. In our second attempt, we have a single term and only 2 factors. Therefore, this is the correct answer. Moving on to question B, this also took me 2 attempts, but I'll just show you the correct one. What I did was rearrange this expression so that this term and this term took each other's place, where I have x squared plus 2x plus 1 minus 9a squared. By factoring through trial and error, this can be factored into 2 factors. What 2 numbers multiply to 1 and add to 2? That's easy, 1 and 1. So I broke it down into x plus 1 minus 9a. These are twins, so we can write it as x plus 1 squared minus 9a squared. Just like in the previous question, this is a difference of squares, because this is a perfect square and so is this, leaving us with x plus 1 and x plus 1 in this bracket. The square root of 9a squared is minus 3a and plus 3a. That's the answer to question B, and that is how to factor by grouping.